I guess a good place to start would probably be to open up Visual Studio. So, man, I probably should have written a script for this. Oh well. So basically, I'm going to start by just creating a new project. I think I'm going to go with an empty one. And then I just name it. Alright, so the solution is basically going to be just like this big folder, and it's going to contain a whole bunch of different projects. I'm just going to make this tutorial project 0, and that is just going to be the name of the starting project that's just going to be there by default. Or something, I don't know. Basically, it's just going to be the one that I'm going to start out with working in. Man, my chair is squeaky. I was waiting for a file to load, but there was no file to load. Alright, so now that the project is brand new and open, I'm just going to create a new CPP, and I like to call it main, because that's where I'm going to put my main. I get the sense that this is not really that tutorial-ish. Anyway, because this is an empty project, it hasn't given us a main function, so usually the best way to write that out, or at least the easiest way that I know of, is just int main, parentheses, and curly brackets, return 0. Just add some space, and then I can put my code there. So basically, the reason for that is because when the program starts, the first thing that it does is it looks for an entry function, which is, at least in Visual Studio or something like that, called main by default. It doesn't have to be main, I've been told, but it's just become, you know, the custom. So why is this return 0 here? Well, to explain that, I'm going to have to explain what a function is. Hello. So a function, man, I'm already getting into that stuff now. Man, I should have put more structure into this. How do I put this? So basically, a function, I'm not confused about how to explain this, I'm just confused about whether I should start with a function or if I need to start with something even more basic than that. I guess the first thing that I should explain is what an int is. So an int is basically just a number. And here's where the first visual thing is going to be. Alright, so basically, if you imagine that your computer is just filled up with all these little blocks of memory, and each one of these is a byte, it's going to contain about 8 bits. Actually, basically exactly 8 bits. 1, 2, 3, 4, 5. Numbers. I really should have thought this through better. So a bit. Let's say that this here is a bit. That's a 0, and this is a 1. That is 1 bit. Or I guess the two states of 1 bit. You can have either 0 or 1. And basically what that means is just that the computer has electricity going through that little spot on the circuit board. So if you put together about 8 of those, you get 1 byte. And 1 byte is basically the smallest thing that your computer is willing or able to work with. I mean, technically it's able to work with the individual bits, but that's actually a little bit harder for it. Oh man, this is really scattered. I'm so sorry if I'm making this difficult to understand. There is so much that needs to be explained to understand so much of this. Okay, I'm just going to put a little bit of separation between these two sets of 4, just so that then you can more easily count 1, 2, 3, 4, 5, 6, 7, 8. Why would you throw your cereal at the screen? I just started it. You haven't really missed much of anything. I'm still trying to figure out what I'm trying to explain first. Okay. Anyway. Actually, wait. This is way too physical. I feel like I should probably explain what an integer is in a more human way. So, when you think of a number, you probably think of stuff like 1, 2, 3, 4, and so on. And that's basically what, you know, a whole number is. You've also got, like, 0, -1, -2, that sort of thing. And those are the negative numbers. As long as you can count a number and there is no decimal part, so like no 1.5 or 5 point some random number or 3.141592653589793, you get the point. Anytime that there is not a decimal, it's an integer. Well, real numbers and whole numbers are different things actually. A whole number just means any number which does not have a fractional part. So a real number is any number that is real. Okay, that's a bit confusing. Let me pull up a chart. Whoops. So basically you've got the whole numbers, which are specifically positive numbers or 0, which have no fractional part. Basically, a whole number is just any number that could exist in real life. Or I guess a real number too, though they're both... Yeah, you're right, that is kind of the same. But, a whole number is basically anything that you could count 0, 1, 2, 3. How many of this thing do I have? Do I have, like, 1 circle? Do I have... Okay, so I have 1 circle, 2 circles, 3 circles. That's a whole number. But then there's also this idea of negative numbers. Basically, if I have 3 of these, but then I have these other ones that would subtract them, then basically I would just combine those, and then I would no longer have either. I should make this a locked layer. There we go. Then I would basically just... I'm so sorry. There we go. Now it's locked. Okay, point is, an integer can be a whole number, but it can also be a negative whole number. And the fact that it can be negative allows you to do more interesting math with it, because then you can also remove existing objects. So like, if you have 3 whole circles, and then you have 2 negative circles, or let's make that blue versus orange. Yeah, so then you've got 3 orange whole circles, and then 2 negative blue circles. And what that would mean is that then you combine those, and then you only have the 1 whole circle. So basically that's what an integer is. An integer is this or this. It can be either one, it can be both. Not at the same time though, because you can't be both positive and negative simultaneously, then you're just 0 or something. I don't know. Assigned 0 would be really weird, but it can be possible, I guess. Although in that case it's a bit of a glitch. Anyway, so that's what an integer is. It's just a number. Specifically, it's a number which does not have, you know, a partial. You can't have a half integer, is the thing. You can only have these whole ones. And basically, that means that then you can have a counting. Okay. I'm making this really complicated for such a simple thing. I'm sorry. Okay, so that's what an integer is. I mean, 1 plus 1 is equal to 2. However, if you're using a char, funny story, if you're using a char and you add, okay, just a sec, 255, that right there is the maximum number for a char. If you add 1 to that, you get 0. Pretty fun. I'm going to just show you how that happens. Oh, whoop. Does that work? Oh, right. Looks like I'm gonna have to include a file now. Include. There we go. Now we have printf. And this will allow us to see what the results are. What? Oh, I'm sorry. I was thinking of an inside. There we go. See? You have 255, you add 1, and then it's no longer 255. It suddenly is 0. Man, this is unstructured. I am so sorry. I really should have thought this through a bit more. I'm sorry, where should I start? Okay, control statements, types, memory. Okay, so I guess that a good place to start would be, maybe explaining all of the different basic types. So basically, there's char, which is 1 byte. Then you have short, which is 2 bytes. Then you have an int, which is usually 4 bytes. Although, that can be kind of system dependent. Usually, it'll be 4 bytes, but just know that in some cases, it could be 2 bytes. So just be aware that that isn't always a guarantee. And then after that, you've got a long. And a long is usually either, well, actually it's just 4 bytes. So basically, if you have an int that is 2 bytes, you can use a long and be pretty sure that it's going to be 4 bytes. But, you know, int. And then, for some reason, there's long. And that has 8 bytes. Just a sec, I'm going to pull up a chart just so that then you can really understand. You know, just so that then I can make sure that I'm not misinforming you. Basic data types, C++. Alright, yeah. So you've got an int, which is 4 bytes. Oh, right, these are the ones that I haven't gotten into yet. There's also bool. And then there are the non-integer types. In the decimal types, there's float, and there's double. The float is essentially the decimal equivalent of an integer. They're both the same size, and while they don't have quite the same range, so like 0 to 255 when unsigned, false or true. Let's see. Let me just real quick calculate what that would be. 2 to the power of 8 is 256. 2 to the power of 16. Alright, so that's the maximum size of a short. And unsigned. Then you've got 2 to the power of 32, or that humongous number when unsigned. Wait, aren't... Yes, those are for comments. All of this stuff, these are all comments. This is just me trying to show information about the code without actually affecting the code. Because if I were to uncomment this, that would not be valid code. The computer would not know what to do with this, and it would not let it would not allow my program to compile. So I comment it, and that allows you to know what's going on with this without actually affecting it. basically, this is just stuff that allows, this is basically just stuff that allows me to communicate to myself in the future or to other programmers on my team, stuff about the code that they might not realize just by looking at a line of code. Because maybe there's something that my long is doing that isn't specifically to do with just storing a number. Maybe I'm using it for bit flags, or maybe I'm using it for a pointer to something. I would want to communicate that to somebody so that then they would understand what's going on. And that's kind of why I'm commenting this stuff out, is because I want you guys to understand. But no, comments don't actually do anything other than communicate to other programmers. When you compile the code, the comments literally just go away. That's basically what the computer sees. It just goes away. It's just for you to comment and tell other people what the code is doing. 2 to the power of 8 times 8 is 64. That is a big number. Alright, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, I know it's not that. Whoops. Include limits. Long max. What is that? Alright, so this is the maximum value of an unsigned, of a regular long. And this is, oh gosh, that's the maximum value of an unsigned long. Oh, what does short mean? Good question. Okay, so a short is basically just it's basically just another type of int between char and int. Let me draw a picture of this. Okay, so let's say that this is your byte. That is 1 byte. So basically, this is what a char is. That's a char. Oh, I should probably name it char. And then you've got short. And a short is basically 2 bytes that are just crammed next to each other. And then you've got an int, which is 4 bytes crammed next to each other. And then, whoops, you've got a long, which is an enormous 8 bytes crammed right next to each other. Although remember that this is basically just the usual. So a long could be 8 bytes, but it could also be just 4 bytes. And an int could be 4 bytes, but it could also be, whoops, it could also just be 2 bytes, depending on the system. A long, however, will just always be the full 8 bytes. Oh gosh. And remember that a float is the same thing as a 4-byte integer. It's just that it gets interpreted in a different way. Okay, so they're basically comments. What does short mean? What's wrong? What is it that is not making sense? I'll try and explain better, but I kind of need to know what's confusing you. I'm sorry. Oh, that's good. Yeah, that is basically what it is. So these are all the different capacity types. You've got the 1-byte capacity, which is a char. You've got the 2-byte capacity, which is a short. You've got the 2 or 4-byte capacity, which is an int. You've got the 4 or 8 capacity, which is a long. And then you've got the for sure 8-byte capacity, which is a long. A long can store much more. Well, it's not commands. Again, these are memory types. They don't store commands. These are primitive types. They don't store commands. They just store bits. So a char can store between 0 and 255. So that means that it can store 256 total different combinations. And the reason for that is because if you were to take this byte and cycle through every value that it is capable of storing, you would start out with 0, and then this right here is 0, and then you would increment that by 1, making it 1, and making this true, and that's a separate value. Then you would make that a false and make this a true, and then you would have 2. Basically, you can think of this as being the number places. This is the 1's place, this is the 2's place, whoops, 3, 4, wait, no, I'm sorry, 4, 8, 16, 32, basically, yeah, it's kind of the same way that you would count in regular numbers. You've got 0, 1, I'm sorry, I don't know why it keeps defaulting to black. That's really hard to read against this background. You've got 0, 1, 2, 3, but then you start getting up to the 10's place, and then you've got 10, 11, 12, and so on. And so then in regular decimal counting, yeah, basically in binary, you have the same system as decimal counting, except that instead of going up by 10 each bit, you go up by 2, or you multiply by 2. So where you would normally have 1, 10, 100, 1000, the computer isn't able to store bits of 10 times data. They only have true or false. So that's only 2 states. Oh, right. The computer isn't able to store that many different states. It can only store true or false, and so it can only go up by multiplying by 2. In decimal, however, we count by 10, because otherwise the number would have to be absolutely ginormous to count the kind of numbers that we see every day. Because basically, if you want to count 32 different things, in decimal, that only takes 3 2. And that's very small, and you already have an idea of about how big it is. But then in decimal, you would have to have 1 0 0 0 0. And that's the same number. So basically, binary numbers just get really big, really fast for telling the same information. But it's what computers understand, and it's very, very fast to perform mathematic calculations with binary. Like, really easy. So basically, like, if you wanted to multiply a number by 2 in regular decimal, if I wanted to multiply 32 by 2, I would have to go through each one and say, okay, 3 times 2, that is 6. 2 times 2, that is 4. In binary, however, all that you have to do is add a 0 onto the end of it. And that's it. That's a 64. Binary is compared to char, short, int. Well, what do you mean? What do you mean it's shiz compared to those? Binary is these. These are all just binary. See all of the little circles in them? Those are the bits. These are all the trues and falses inside of the bits. So anyway, the reason why a char is called char, by the way, is because it's, and anyway, you use those as a base. You use those to store numeric values. So if I wanted to store the number 356, I would want to do that in an int. And then I would basically go through, just a sec. 0, no, 1, 2, 4, 8, 16, 32, 64, 128, 256, 256, 512, 1024, 2048, 'So then let's give each one of these numbers a bit. 1, 2, 3, 4. 1, 2, 3, 4. Okay, we're missing one. 2048, 40, 96. Just a second, I'm trying to figure out a good way to display this. Alright, I think this should be good. Okay, so learning how to do this. Well, it's not so much that. It's basically that you want to be able to store values. So an example of a time when I would want to store a value would be, let's say, if the player presses the M key, and I wanted to say, every time that they do that, I want to increment a number. So I want to say, how many times did they press the M key? How many times was the M key pressed? Well, that would start out with 0, because at first they haven't pressed it, and then they would press it again, and it would be 1, then 2, then 3, then 4, then 5, and every time that they pressed the M key, that number would go up. If you just want a value of 4 to exist, you would just use a char. Well, it really depends, because you don't really need to store the smallest possible value. Sometimes it really depends on what possible values that could be, because maybe you're trying to store a value that could be any number, but it just happens to be 4 right now. If it just happens to be 4 right now, and you want it to be able to be a number that could be much higher than 255, then you would want it to be an int. Because if you have just a char, then you would be confined to specifically 0 through 255. Because once it hits that 256 bit, a char just goes back to 0. So then you've lost all of those values below 255. I mean, you could store a single byte, but you don't have to. And really, it just really has to do with the usage. A char is actually called a char because it is by default meant to be a character. So a letter between A and Z, but it can also be a symbol like an exclamation point or a period or a semicolon. Basically anything that you could type on your keyboard, you would be able to store in a char. An int, however, could be effectively any number that you would want to reasonably use. Like I show here, the maximum value for an integer is so high, I really doubt that you're gonna need to reach that number at almost any point. A long, however, or a long, is used for addresses, so there's that. Anyway, this isn't actually like the memory management part of memory. These are just all of the different base types that more complex types would be built out of, and that you would basically build your code off of. You kind of really need to be able to store values to do just about anything. So for example, something like if I wanted to make a vector 3, I would have to store 3 floats of x, y, and z. And those are all the base type float. So basically, these are just all of the different types that can store just plain numbers. Wait, what's the difference between a float and a double? Okay, so a double is a float, but with twice the bits. So if I go back to my visual example, a float is 4 bytes, while a double is 8 bytes. So basically, a float is the integer. A double is the long equivalent of a float. So double is to float what long is to int. That's basically what the difference is. You can have not really twice as many floats. Well, no, you can. It's not so much that you have twice as many values. You actually have twice the precision. And so that means that, well, imagine you have a float value which is just 0.000001. If you were to make the same number in a double, does double does not exist. Currently, the most bits that a processor is able to handle right now are 8 bytes all at once, or at least in a single type. So in order to have a double, you'd basically have to come up with a way of having, 16 bytes. And nobody's CPU is able to handle that at the current time. So already a double is at like the maximum amount of memory that you can really process at once. If there was a 16-byte if there was a 16-byte CPU, then yeah, there could be a double-double. Technically, you could combine two doubles into a single thing. But the issue with that is that then you have to define all your own math, and then you can't really have the same kind of precision that comes with the basic double type. Because, you know, it isn't built into the computer. Computers these days are designed with doubles built into them. They already have a very hardware-based understanding of how doubles operate. They do not have a baseline understanding of how a double-double would work, so it would be slower and probably not as precise. You'd have to define all your own math for it, and it probably wouldn't work as well. But anyway, those are the different basic types, pretty much. Now, another thing is that you can also have signed and unsigned variants of them. And what that does is it basically makes it so that then you can have, like, specifically negative to positive, or you can have 0 to very high positive. So basically, you trade off the ability to have negatives in exchange for the ability to have twice the highest value. How do you instruct a value to go to a certain int or flat? Okay, floating point. So the way that you would tell a variable to be a certain value is you would first say, here is my float's name, my float. And then you would say equals my value, which is going to be, let's say, 5.001f. Because you got to have a decimal part and the letter f for a literal float. If you don't put in the f, it's just going to be a double, and then it's going to have to do the extra step of turning that double into a float. So if you're doing a literal, you might as well just add the little f there. It's one character, and it saves your compiler a bit of trouble. So basically, that's how you would tell my float to now be 5.0f. It now has that value. And then if you wanted to change it again, you would just do the same thing. My float equals 10.0f, or 10.5f. That's basically what you would do. You would just say the name of the variable, and then you would put equals whatever value you want it to be. No, you only have to end it with an f if it is specifically a literal float. What that means is that you have a float which you are defining as a number in your code. So if you were to set your variable to another variable...
Here's what I found.
Shush. I wasn't talking to you. So if you have two variables, my float 1 and my float 2, you would just say the name of the other variable without saying the literal, and you wouldn't have to put the f, because it's already a float. Now the thing is, though, if my float 2 is actually a double, and it is my double 2, or my double, then there would have to be some conversion involved. It would have to convert from a float to a double. And basically, that's the syntax for that. Although, there is such thing as implicit conversion, or implied conversion. So if you just have... Oh, whoops, I forgot to make this my double. Because these two types are similar enough, and because there is some compiler-based, conversion that is known, it will just convert that into a double on its own. It will secretly put in the double conversion, or it will put in the double cast or conversion just on its own. And it just won't tell you. Let's see. Sometimes it expands it, sometimes it doesn't. But basically, because there is a defined conversion from float to double, you don't have to put this, but it usually is more... It's usually better if you do that. Because that just explains, hey, this is a float, but I'm using it for a double right here. And sometimes, if you're doing math with it, you absolutely have to do that, because otherwise it'll tell you, hey, you're losing precision. If you don't do this, you're gonna have a bad time. It'll give you a little green squiggly. Hang on. Okay, I guess it doesn't want it this time. But sometimes it will give you a little green squiggly that says, hey, this value right here, this variable, has twice as many bytes as this one. And you're trying to add together these two numbers before turning it into a double. You might want to be careful because, let's see, for a better explanation, let's do an int and a char, or a char and an int. So for a better explanation of that, let's see, my char, my int one. So basically, if my char is already equal to 255, and then we add 5 to it, it's no longer going to be 260, it's going to suddenly become 4. And the compiler will see that and realize, hey, are you sure that's what you want? Are you sure that you want this type, which has 4 bytes, to be set with a value which might be wrapping around to a different number? And it'll tell you, maybe you should change this to an integer first. And then that way, when you add them, you won't have the wrapping around issue. So if you have these two lines of code that are the exact same, except for that one of them is converting to an int first, this one you would have my int equals 4. But in this one, you would have my int equals, my int equals 260. Because 5 plus 255 in char land, d$v. Currently I'm just making a tutorial. It's not so much a game, at least not for this stream. I will be working on a game next stream, but this one I just want to explain all of the coding stuff that I can, so that then people have an easier time following along, and because I really want to help, learning developers to learn. There's a lot of things that I've seen in tutorials, or that I haven't seen in tutorials, that I feel like I really wish that people would make tutorials about that, and so I'm trying to do that for this. I want to go through and explain everything as well as I can, just so that then other people can understand the same stuff that I do. So yeah, basically my char 255 plus 5 equals 4. And the reason for that, well, I guess that I haven't really explained wrapping around yet, have I? So, if we take away all of this, see you later. %i/n. Alright, I'm just going to make a real quick function that just prints out whatever the value is. My value now is void Alright, so what this is going to do is it's just going to print out whatever the value of my variable is. And that way we'll be able to see what the value is as the variable value changes. So then, if I make var equal 255, then printing it out, it'll be 255. However, if it's a char, and then I add in this extra line that says var equals var plus 1, then it becomes 0. And also 255 is negative 1 for some reason. I'm going to explain that real quick. So basically the way that signed types work is that this first bit suddenly no longer actually means a new value. Instead it means whether or not it's a negative. So then when this is true, then it's a negative. And when it's false, it's a positive. And then you just have these 7 bits to explain the remaining value. And that is just enough in a char to count up to 127. So normally you'd be able to get double that with 255, but instead you're restricted to only 127 with the additional negative. And so when you put in specifically 255, then you would get negative whatever it is. So if I were to put in 256, then it would be 0. Because 256 as a char is 0. It just, it wraps back around because all of these being true equals 255, but then you add 1, and it doesn't have anywhere to store the last bit. So it pretends that there's this new bit, which was previously 0, and this is going to be our 256 place. that becomes true. And then, because of the way that binary works, all of these become 0, and then you just start counting as though this was the next bit. But this is not a bit, it does not exist, so you've basically just lost that information. So that's why you want to convert to an int when you're using a char and then you're using it for counting a larger number. So if I basically wanted to have something that would always print out what the value is plus 10, it would have to be an integer. Or, I don't know. Okay, so basically you would want to convert to an integer before adding the 10. Because otherwise... Okay, so let's make char my var equals 0, print value my var for 0 is less than oh, whoops. I keep forgetting that chars are not unsigned by default. So if I do that, it's going to start out... What? Oh. If I do that, it's going to start out... I was trying to show what the wrong one is first. Okay, so... if we do that... Come on... Okay, I guess that you're totally allowed to do that. Completely disregard what I just said. Do whatever you want. Just do whatever, whatever. Apparently it doesn't matter. Where was I? What was I gonna explain in this stream again? Man, I've spent a long time on just basic types. Huh. What should I explain next? I guess... since we're still on, you know, types, there's another one, an enum. An enum is kind of like if you were to explain, well, no. Okay, so an enum is essentially just a number. It is still a number secretly. You don't have to put that part in. But by default, an enum is an unsigned long. You can have any number that you want in there. And it starts on 0, so if I make apples equals 0, then oranges equals 1, and then bananas equals 2. You could technically just leave out these parts, and it would secretly be 0, 1, 2. Although, usually it is nice to explain specifically 0, 1, 2, but you don't have to, because this part is implied. However, if you're doing more complicated stuff with this, like let's say that I wanted to have a flag. I haven't explained flags yet. Anyway, these are secretly just numbers with names. So if I do this, this is effectively just setting A to 0, because apples is 0. And if I take out this part, it is still 0. A equals 0. Oh, and by the way, notice how it's implicitly converting to an integer right there. So basically, you could have effectively, this is just a number with different settings. Oh gosh. I am starting to confuse myself. It is hard to put this stuff into words. Right. I have visuals. Okay, so let's see. An enum. So what is an enum? Let's say that I have this object, which is a circle, but that circle doesn't have to be a circle. It could be a square, or it could be a star. And I want to say whether it's a circle, square, or a star without having to, you know, make entire different types for these things. Maybe I just want to have a singular, it could be one of these things type. So the way that I could do that would be with an enumerator. And I could just say it's either 0, which is a circle, because 0 kind of looks like a circle, or it could be 1 for a square, or 2 for a star. And that's essentially what an enumerator is. It's just a number that represents something other than a number, and in the code, you can use the representation to mean the number. And it works both ways. So if you say 0, secretly you mean circle. Or if you say circle, secretly you mean 0. Basically, an enumerator is just a state with a number. Like a state as in... Why is coding so difficult? Gosh. I swear it makes sense once you understand it, but it's so hard to learn. My gosh. Alright, so if you think about an enumerator, let's say that I have a thing where it takes in one of these objects, but it can only be one of these 3 objects. Okay, that's a bad way of putting it. Takes in. I still haven't explained what a function is. Okay, I'm gonna try and do this as visually as I can. So a function is basically a return type, a name, and then it is parameters. Let's make this one orangish, this one green, and this one gray. Or, I guess, blue. Yeah, that looks nice. Actually, let's make this sort of purpley. Yeah. So in code, this will effectively look like my type, my function, type, my param. I hope that's readable. Let's just make this also blue, since usually types will be blue. Or maybe it's green. So essentially, this is what a function looks like. It's just the type of the return followed by the name of the function followed by the parameters and their types. That's the syntax, though. Late night, I'm trying to understand what's going on here. Guess I have to watch it from the beginning. Maybe you might, but that's up to you. So basically what a function does is every time that I call this function, so every time that I say my function and then I pass in my value, and let's make this a nice cyan, because usually that's the color that a variable will be in Visual Studio, if it's a local variable, anyway. So then every time that I put in this line of code, this is effectively saying whatever's inside of the curly brackets here, do that. Just every time. Now, the reason why you pass in parameters is because you might want your function to do something with it. So, let's say I have a function which I want to right, so this is my function signature. and then this is my function's body. So what the body will do is it will effectively just, let's put in some nice little curly brackets. So effectively what this is saying is, every time that I type this, do this. So basically, when I put this line of code in, then do this. And usually what this will do is it will take the parameters. Okay. Okay, let's make this blue. I'm sorry, I really should have made some stuff before starting this stream. I'm so sorry. So basically, it will take these parameters and it will perform whatever code you tell it to in here. And if you have a return, oh, just a sec. Gotta answer this. really should have made this a lot more structured, but I didn't. And so let's see. Why would you? Okay, so this is basically the syntax. So what you would have it do is int function test int parameter return parameter. And that's just a very, very basic function that literally just takes in a number, int myvar equals 0, and all that it does is returns the value of myvar. This is a very silly function, and you probably don't ever need it, but an interesting thing about this is it's taking a copy of this and returning a copy of it. So basically what it's doing is it's just giving you the value 0 instead of giving you the variable myvar. So if I were to have int myCatcher equals the value of myvar, it's not going to take myvar. It's going to take whatever the value of myvar is at that moment. So then I could have myvar plus 1, and myvar would still stay the same, but myCatcher would take myvar plus 1. Again, this is very silly. You could just do this, and it would be exactly the same thing. So usually what you would do is in a function, you would probably be having the function do something to your number. So let's say, for example, that I want a function that will, whenever I call this, add 1 and divide by 2. And that's pretty useful because usually what that would be doing is turning a 0 to 1 value to, wait, no. Okay, I just got both of those things confused. Okay, so I would want to multiply by 2 and subtract 1. And basically that would just times 2 minus 1. And then effectively what this does is it converts a 0 to 1 integer to a negative 1 to 1 integer, which is in fact kind of useful in some cases, although usually it'd be more useful in a float. Unless, of course, you're doing an integer that is larger than 1, but then you would have to know whatever the maximum value is, so usually float. So then if I were to have myvar be 0 to 1, then this function would turn it into a negative 1 to 1, which is useful. And because of that, I now don't have to write this line of code every single time that I want it to do that. So I don't have to have myCatcher1 do this, I don't have to have myCatcher2 do this, I don't have to have that, I don't have to have that. All that I have to do is just write float myCatcher equals that of my catcher. And then that right there does all of that. So let's rename this function to just widen, because that makes a bit more sense of what it's supposed to be doing. It converts a 0 to 1 into a -1 to 1. And it does it with whatever you put in as a parameter. It can be a variable, it can be a literal, that's about it actually, just a variable or a literal. Hello! So essentially a function is just something that will perform a line of code to whatever parameters you have. So if you notice that you're doing a specific operation really frequently that you want to always have be exactly identical, you could just write a function to do that. So like, let's say that I notice that I'm very frequently performing the operation of integer my val. Hi, the Fanger. Hi, Mr. M and Mr. B. Okay, just hi everybody. I'm sorry. Okay, int my val. Let's say that I notice that I am quite frequently taking my val, adding 1, subtracting 2, multiplying by 47, and then dividing by 8. And I'm doing that all over the place. It might be much easier to just use the singular function that does all of that at once. Oh, by the way that I'm selecting two things and doing the same thing to both of them simultaneously is first I press the first one, then I hold down Control and Alt at the same time, and then I click on the next thing. It's very useful. I use it very much. So basically, instead of having all of these lines of code where I have the possibility of accidentally writing one of them wrong, or one of them being slightly different somehow, instead of me accidentally writing it wrong, or misremembering how it's supposed to work, I could just have the one line of code, my val, and then in all of the places where I'm having it do that, I just have it do that. What's it mad about? Oh. But also, another thing, for loops. Let's see what the syntax for that is. So this is just the literal word for. It's just the word for. And that's how you first start with a loop. Then you would have your loop parameters, which are first the variable, semicolon, okay, bring to front. So it's going to be first the variable, then it's going to be the condition. So basically, as long as this condition is met, it will continue to loop. And then you have just a increment, I guess. And then you just have a closing parentheses. And effectively what this does is whatever is inside of the curly brackets, it will repeat this as long as the condition is met. So it will just repeatedly do this as long as this condition here is met. I'm going to make the condition red because I associate booleans with red. I'm going to make the variable blue or cyan because usually variables that are local will be blue/cyan. And then the increment is going to be orange because it is effectively a function that will be called every time that the for loop is called. So first, what it's effectively doing, so this is what you write, but secretly what it's doing is it's performing a check of if condition equals true, then then perform this code. Well, actually, first, well, yeah. Repeat this code using the variable, and then, lastly, increment. Or just whatever is in this orange box, it will do that after repeating this code using the variable. So essentially what the for loop is secretly doing is for int I equals 0, I is less than 10, plus plus I, so what this will do is essentially for 0 through 9, because once it reaches 10, it will no longer be less than, it will be equal to, and it will exit the condition. For each value of I between 0 and 9, it will write this. Okay, so another way that this works is while true. This is bad form, or well, not really bad form, but you know, just don't do this. Don't do exactly this, because you will break your computer. So essentially what this right here is doing is it is first saying, I'm making this new scope with the integer I, which is now equal to 0. Or wait. First I'm going to, while this, just while true, so forever, or until break, create this new integer I, which is going to be equal to 0, or actually it does that first. Then it says to do, oh gosh. If I is less than 10, do that, and then increment I. And if I is not less than 10, it will break. And what break does is it exits this while loop. So break essentially, just a sec. So when it reaches break, it will just go down to here. Well, first it will say, what am I breaking out of? Well, there's this scope, but you can't, well, there's this scope, which I'm in, or this scope, I guess. I'm in both, but I'm not able to break out of those. You can't break out of if statements. So then it goes up another level and says, well, there's a while loop over here. There's this scope right here, and that's a while. My gosh. There's this while loop here that I'm also in the scope of. And you can break out of while loop scopes. So then it says, well, where's the end of this scope? That is right there. So then the break takes me to there without reading this. It'll just skip over this, just skip that, go to here, and exit. And now we're outside of the loop. That's what a break does. So a for loop is basically just shorthand for all of this. Create this integer, or create whatever type this is. It doesn't have to be an integer. It could be like a char. It could be a short. It could even be a personally defined type, as long as you have some way of putting it in here. This is harder than I thought. Is what I'm saying making any sense at all? At all? I hope I'm making sense. I hope I'm not just saying stuff that nobody understands. I wonder if I should explain what an array is. So this is basically what an array is. An array is type which is going to be green, I really can't tell if anybody's understanding or not. Anyway, an array is basically just bundling together multiple different variables and giving them all positions. So you've got 0, and that is the start of your array. Then you've got 1, then 2, then 3. And so then you've got these 4 different blocks of memory. And if you just say name, it'll give you this. Or rather, it'll give you the position 0. Okay, this... I'm going to have to explain pointers. Oh, gosh. I probably am not a good teacher. So basically, an array is just a container of all of these different elements. If anybody wants to like ask a question or anything, I'm happy to answer. I don't really feel like I'm explaining this all very well, so I'm gonna end the stream for a bit, and I'm gonna go on a walk. I'll be back later.